The next poster will be presented by Shirel Azogy from Lab Center, right?
Yes. Hi. Alzheimer's, dysgraphia, DCD, they are all deficiencies that affect a patient's abilities to perform simple or daily movements and manage a normal life. An early diagnosis of such problems can save the patient a lot of inconvenience and improve his quality of life significantly. The diagnosis, performed by trained occupational therapists, uses a set of handwriting evaluation tests, but those tests are limited to characteristics which are observable to human eyes and influenced by the therapist who does them. The testing is often repeated using extensive time and research components that are always in shortage. Imagine an application that can analyze a patient's handwriting to point out if and which characteristic is problematic and provide the specific deficiencies that the patient suffers from. Until a few decades ago, it's homogeneity, but with the blossoming of advanced data analyzing and data mining, it isn't. With the generous help of Professor Rosenblum, we receive handwriting data of poor and proficient patients with all kinds and severity levels of deficiencies. Dr. Richenso and I from Lev Academic Center invite you to hear more about the methods we use to analyze this data and the results we received. Thank you.
The next poster will be given by Ariel Bar from Information System Engineering here in BGU.
Hi everybody, good afternoon. My name is Ariel, and this is a joint work by Bracha and Lior, and of course Moshe Unger. I'll be talking about honeypots. Honeypots are computer resources that their main goal is to attract attackers. We want attackers to explore our honeypot framework so that they can leave traces about their ways that they attack, and then we can analyze them and prepare better solution for defense. In particular, this poster will be about the problem of propagation of attacks, an attacker that attacks several honeypots in a sequential order. And this is an example for how our final model looks like. It's a graph that represents each node on it in a honeypot and the interactions between them. Overall, our novel method has a prediction model, a segmentation of honeypots into groups that we can see by the colors. We can detect new and evolving patterns, rank the honeypots who contribute the most to the attacks, and have some contextual modeling also. All the implementation was ready for big data, and we evaluated on a massive data set of real attacks with more than 160 million attack records collected for 1 year of period. Okay, thank you.
Thank you. The next poster will be presented by Aviad Cohen, also from the Information System Engineering.
Hi everybody, my name is Aviad Cohen and I will present the paper SFEM, a structural feature extraction methodology for the detection of malicious office documents using machine learning algorithms by Mr. Nir Nissim, Professor Lior Rokach, and Professor Yuvalovich, and me. As you all know, office documents are widely used by individuals and by organizations. Office documents, as the contrary to the popular belief, are not safe to use and can perform malicious actions. Attackers increasingly leverage office documents in many recent cyber attacks, and the main problem is that existing tools fail to detect new and unknown office malicious documents. Our goal is efficient detection of malicious XML-based office documents, and we do it by using SFEM to extract discriminative features from documents based on their structure. By leveraging these features with machine learning algorithms, we can achieve efficient detection of new unknown malicious documents. As you can see at the right side, you can see an unzipped Word document. Yes, office documents can be unzipped. And you can see a directory which built hierarchically, which contains files and folders. Part of them are XML files which are also hierarchical. We convert them to a structural path which we consider as features, select the most prominent features, and train machine learning algorithms. To hear more, come to see the poster. Thank you very much.
Thank you. The next poster will be given by Elena Churkin from Shamoon College.
Hello everyone, my name is Elena Churkin. I am participating in the development of the automatic summarization tool named MUSEEC. This is a multilingual tool which uses 3 different approaches for summarization. The first approach, named MUSE, which is supervised summarizer that use genetic algorithm for learning. Okay? The second approach named Poly, and it is unsupervised summarizer based on linear programming. And the third approach named VCOM is unsupervised summarizer based on compression of sentences. All approaches showed a good result in the international competitional multilink in the past year, while MUSE took the second place in the English, Hebrew, and Arabic languages. In this work participate many peoples, Mark Last, Natalia Vanetic, Marina Litvak, and many others contributes to this tool. Thank you very much.
Thank you. The next poster will be presented by Eran Fainman from Information System Engineering.
Hello everyone, my name is Eran Fainman and I'm a master student here in the Department of Information System Engineering. And my advisor are Professor Baruch Shapira and Professor Lior Rokach. My poster of today is present the dynamic cost-sensitive feature acquisition framework for mobile context-aware applications. The problem is that when we build a mobile context-aware application, we can sample many sensors and to extract many features from these sensors. And so we need one of the major inherited challenges is to determine which of the features to acquire during the sampling process. The amount of required feature affects the application's resource consumption and the resource in terms of CPU and memory, the response time, the context-aware inference accuracy, the communication overheads, the storage, and the data manipulation capabilities. The poster presents a framework that involves machine learning techniques in the sampling process in order to improve the performance of the sampling process and the performance of the whole application. The feature acquisition is performed in 2 steps. The first step is the initial step in which we acquire all of the features, and the second step is the dynamic step in which we sample features according to our prior acquired data. We show that by using this framework with a tree-based configuration, we achieve 80% of cost savings and around 10% accuracy loss. If you want to hear more, I'll be happy to expand during the poster session outside. Thank you.
Thank you. The next poster will be given by Asi Mesika from Information System Engineering.
Hello. So my name is Asi Mesika, and I'm a student here. Professor Lior Rokach is my advisor. How many of you like to buy products in sales? How important it is for you to get discounts for your product? How much does it influence your purchasing decision? In this research, we had conducted an experiment for coupons for restaurants, and we use the data in order to model the different customers' sensitivity to discounts. So the coupons were from various levels of discounts, and our goal was to predict to provide actually the best coupons recommendations for the users in order to optimize both the business KPI, the conversion of the coupons on the one hand, and the savings for the customers on the other hand. And we got some interesting results. So what we show here is that different users respond differently to discounts. Some people are strongly affected from the amount of discount. So in this experiment, more attractive restaurants, which are more popular restaurants, or restaurants which are closer to the position of the customer, has lower amount of discount, and less attractive customers has a higher amount of discounts. And what we can see is that some people, when they got a higher amount of discount, they will go to less attractive restaurants, since they are very sensitive to the amount of discounts. And some customers are not or less sensitive for the amount of restaurants, and they will keep their original preferences and go to the restaurants that they like most. We also this is what we explore from the behavioral of the customers. And what we did in our research, we modeled this behavior, this sensitivity to discounts from the commercial data that we have. And we incorporated it into a recommender system in order to optimize the recommendation and conversion. Thank you.
Thank you.
Hello, everyone. I'm Yotam Rotolz. I'm a student for a master in the Industrial Engineering and Management here in Ben-Gurion University. Soil samplings is a method used by farmers for understand soil chemical and physical characteristics. It helps farmers to make decisions relating to farming, like irrigation plants and fertilizers, type and rate, and so on. Soil samplings data is usually stored as layers in a GIS, and it tends to suffer from severe data quality defects. Sometimes the data looks unreliable and the values of it seem inappropriate. My thesis offers a model for reliability assessment of the last transaction of every special object. It considers the values of the record itself, and also it considers the previous transactions of the same special object values, and also the values of adjacent special objects. You can see here on the slide the plots layer. Then you can see the soil samplings layer relating to one of the attributes in the dataset. And eventually, there is the model results, which are the reliability assessment, reliability grade for each special object. You can see the first plot, there is a repetitiveness, which may be derived from a copy-paste phenomenon. Eventually, the metadata layer may support farmers in decision-making what samplings are reliable and which are not. Thank you.
Thank you very much, Yotam. The next talk will be given by Moshe Unger, a PhD student in Information System Engineering.
Good afternoon for everyone. My name is Moshe Unger, and I'm a PhD student here in BGU. This is a joint work with Professor Bracha Shapira, Professor Lior Rokach, and Ariel Bar. And our main focus of the research is to predict users' context and model it with deep learning technique, and also to infer the POI category of the user in a contextual situation. For example, if we take the mobile sensors from the user's mobile phone, and we can predict what kind of POI genre is related to this user at his current context. So basically, our algorithm uses deep learning technique, which is called auto-encoding, for generating behavioral models of mobile sensor data, and then we use it in order to infer POI categories of users. Basically, we have done an experiment with 90 users with a month of 4 weeks, and the users' interactions was like and dislike, and we used this information with their mobile devices in order to predict the POI category of each user given his mobile phone. We also show how we can utilize the deep architecture in order to detect the context similarity, the similarity between the POIs, and also we handle the cold start problem. So if you want to hear about my research, I will be more than happy to explain in the poster session. Thank you, everyone.
Thank you. The next poster will be presented by Barak Yihye from Department of Industrial Engineering.
Thank you. Hi all. Okay, this is a co-research together with Danny Vilenchik. Basically, you all probably know Twitter, social network for microblogging. What we try to do is create some unsupervised method to detect some user classification in Twitter. So basically, we crawled over 3,000 users, extracting from each user 12 features. And then we did a principal component analysis on this feature to reduce the dimension problem from 12 features only to 3 dimensions. On top of this PCA, we did also sparse PCA in order to reduce also the semantic dimension problem. So we left only with few features in each component. Our guideline was to create as much as features that could be reused in other social network. So we won't use only Twitter, so we can apply this also in Instagram, Facebook, LinkedIn, and so on. The result was actually good if you ask me. We got the first PC that indicates how much the user is popular on the network. The second PC that I'm calling it bot versus human, according to the user activity, if he's a robot or a human. And the third PC that shows us how much contact provider the user is. So I will more than happy to get your question outside. Thank you.
Thank you, Barak. Last but not least is Itai Khazan from Information System Engineering.
They missed my poster, but it will be okay. I'll explain it myself. My problem is the location prediction problem, which means predicting the user's next location according to their previous routes and their contextual information. Contextual information can be the current location, the day that the prediction need to be, and maybe the last website they visit before they need to give the prediction. This is not a new problem, but the wide use of smartphones gave rise to it again, and made it even more interesting as we can combine other sensors like the accelerometer or other stuff that even the camera or their usage on the phone, everything that can be combined in order to predict better the user next location. So several improvements have been made in the last years, mainly basically using the Markov model and improving it according to the definite question of if we need to predict it in the next hour or even the next location, what it should be. My research is dealing with improvements, is taking these algorithms and improve them with adding contextual features, basically using them as a black box and improving them and using their output more efficiently. So I'll be also happy to explain it further in the poster session, so see you there.
Thank you very much. This concludes the poster teaser session.